So anyway, last few days I've been having a real headache with this this circuit. I haven't even laid this out yet, and it's a mess. I haven't sorted it out. But this circuit was just that I drew it out myself and worked it out, and it was working fine as a half bridge, but there's too many frigging diodes in there, right? So I was getting a loop. I don't know how to explain it really. Well, because it's AC and it's not DC, strange things can happen. Alternating current and alternating voltage, whatever, you get all kinds of transients and pulses and things that happen to the circuit that disrupt how it's supposed to work. So my trigger coils were basically going into these inputs of H3 and H4, which is the trigger in on H3 and the trigger off of H4, but it's AC, so I'm directing the pulses through my diodes to one half the circuit, and the top half bridge would work. But when you connected both halves together, that's when all the fun starts, and that's when chaos rains down. And so what I'm going to be doing instead is to opto-isolate my input trigger signal so I don't get feedback into my trigger coils. And let's just put that back in the box, because I have to I'm going to open another circuit I designed. Oh god, I'm in the wrong directory as well. Let's give this a minute to load. It's a bit slow because I'm live streaming as well. But I could go and search the library for this component, but it's a lot quicker if I just go and copy the item I want from my previous design that I made. So this H-bridge circuit that I made, actually I put the date on it. I made that in May 2018. Was that around the time my mum passed away? I think it was. Anyway, so I've got some opto isolators on here which I can borrow. Well, I'll show you what this circuit looked like. This is something I designed back in 2018, and this is a 3D representation of that. So that was extremely condensed. That was an extremely condensed circuit board that I made, and it works, and it's great, and I'm happy with it. And if you look, there's opto isolators right there. Those little black boxes are opto isolators next to the LED, and So I'm thinking, yeah, that worked great for my H-bridge, which was creating AC. So I'm thinking, yeah, let's go the opto-isolated route, and we can eliminate all these problems. Right, so close the virtual reality thing down. I just need to go and get them off the schematic actually, which is here. Oh, not here, sorry, where is it? It's over, where is it? It's over here, is it? That's the PCB. Well, where's it gone? Oh, is it over here? I've got too much stuff open on here, that's what it is. Well, I'll just close that thing because I don't need that. Oh, there you are. You are hiding. There's my circuit. So I need to grab it off here. Oh, I'll just grab one of them because I'll copy it then. Saves me going through my library. The library can be a bit temperamental. Actually, why are they numbered wrong? It should be opto isolator 1, 2, 3. Well, I've got the numbers a bit mixed up here, but never mind. So I'm going to copy that one, and I don't need it open anymore. So I haven't changed it. Get rid of that because I don't need that open. So I'm going to paste it on this schematic, and I've got to basically redraw this because it's such a mess. So I'm not actually showing myself on live stream, but I'm just showing my desktop right now because I've got this diagram to sort out. And sorry about the hiss. I've got noise suppression on right now, and it gets hissy and noisy, and it's better than being muffled. And yeah. So. Give me a minute, I was getting a link for a friend. Don't always know where my live streams are. Where's my live stream link gone? That's weird. Must be on the home page. Yeah, there it is. So just give me a minute, I'm just messing about with, I'm just updating people on my phone. Right, so what I've got to do is isolate the input circuit. Now this is a mess, so what I'm going to do is I'm going to get rid of a few things. The main section over here is okay, I can leave that for now, but I want my trigger input still, so I'm just going to get rid of that diode, some of these connections. I'm just going to start with a bit of a clean slate. Get rid of that. I had such a lot of feedback problems with it, it's just, it's bonkers. Right, I'll just get rid of all that, because that's just mess and clutter. I'm going to move all this over here because what else do I need? Well, I'll leave some diodes in for now because I'll probably need a few, but I'm just going to break some connections though, because these connections are not going to be valid. I don't know what diodes I'm going to need, so I'm going to move them up. Oops, I've grabbed that as well. Just undo that a minute. Just move this lot out of the way. Right, so stop it, you get out of the way. Right, I just want to start with a clean slate, sort of, but I don't want to get rid of all of it because most of it's going to still be valid. Right, so I've got my opto-isolator there. That's one of them. I'm going to need two because there's two channels. Let's rotate that. I want it that way around. I'm going to stick these over here. I want some room. Right, so I've got one opto-isolator there. I need two of those, so copy and paste. I've got two now. Right. Yeah, it's a bit of a headache trying to work all this stuff out. I'm trying to do it. I'm just going to rotate that text so it looks a bit better. And that can go out of the way for now. It's just driving me, confusing me. It's not easy to work right now because I've got this breadboard in front of me, and I can't put my keyboard on the table, so I'm having to use it on my knee, and it's really frustrating. Right, so I've got my AC coils coming in on these inputs there, the H3 and H4. They're not connected to anything right now, so basically I need my variable resistors there. Right, I need to adjust the gain on this thing, so I also need to adjust the gain on the input as well. So I need more variable resistors by the looks of it, but they're going to be low values, so just copy that variable resistor and stick that over here. Because this is AC, I'll rotate that around, stick one there, and stick one there. Now remember, these are opto-isolators. If you don't know what an opto-isolator is, it's basically an LED that sends out an infrared signal. That's why it's got these little lines. So you send a signal and it lights this LED, and it's inside a plastic package. It's black, it's completely black, and the light doesn't escape, so it's trapped inside this plastic package, but it's completely separate. You can send a few thousand volts and it won't get through to the other side. Basically, it's completely isolated, and they use these in high voltage circuits. They can drive them with 12 volts, and you can actually be switching a few thousand volts on the other side, which is really useful. They're mainly in lamps and dimmer circuits and things like that, but LEDs as well, LED lights, they use them in that a lot. But the advantage is that you don't get any feedback between what's going on this side here and what's going on the input side, because it's separated by light waves that travel a small gap of a few millimetre, a micron or something, tiny little gap, but it's actually probably more than a micron. It's probably like a millimetre to 2 millimetres, depending on the voltage insulation, but that's what an opto-isolator is. You can probably look them up on YouTube or something. But so I need is to this doesn't want to be 100k though, because that's a bit too high. So what I'm going to do is I'm going to change the value. It probably wants to be less than 10k. So actually I'm going to, because it's about between about 4 or 5 volts coming in, I really want a very low value. So let's see, probably 470 ohm. So 470R, but not ohm, because the ohm signal is difficult to draw in here, but the R represents that resistance. I need to change the other one as well. I don't always live stream when I'm doing circuit diagrams because it's very confusing, but I'm at the early stage, the simple part really, so it's not that confusing. Now my trimmer will adjust basically the amount of AC that is allowed to pass through this LED that's inside this package that I was showing you earlier. So that will enable me. Now it's quite easy for me to cross connect these coils, so the trigger on coil, actually I need that. I don't know why I deleted that. That's on. I've already deleted all the off. No, it's down here somewhere. Saves me typing it again, I'm lazy. And that one's off. So my AC coil will be connected between this trimmer and the end of that opto-isolator, like that, so that it completes that part of the circuit. Then this will go to, I've got it one way around again. I need to flip it, hang on. It wants to be the other way around. Yeah, right, so that will go to there like that, and then I can adjust the volume, the bit. It's like adjusting your volume control on your hi-fi. That's what this is, a variable resistor, and I can send that signal through this. It's AC, so I'm not going to be using very many capacitors because AC will react unpredictably the capacitors themselves will cause problems. So it's a purely passive circuit, this part. So that will basically switch that LED on when the AC is high on this rail and low on this rail. So when it's high on this rail, it will turn that LED on. And this also can be connected to the other opto-isolator, because that one will only turn on, this one will only turn on when these rails are reversed, because AC is reversed itself. So when that's low and that's high, that's when this one will turn on. So what I have to do now is I have to connect this one. Oops, it keeps jumping on me. So actually I'm getting a bit ahead of myself, because this is the off circuit, so there's another coil connected to this, and I want the off coil in series with the on coil, so that when the on coil goes high and there's a voltage going through here to turn on this LED, I want this other off coil in series so that it subtracts the signal away from the on signal. If you understand what I'm talking about, addition and subtraction, it's just a bit of math really. When that voltage goes high on this rail here, we can have this coil wired so that it actually subtracts some of that voltage from that rail and it goes low. So the off coil really wants to be in series with that one, which is where it gets a bit confusing. So let's just remove that. It gets really confusing. But so if we have that in series and we have it there, and then we have this on going through this off coil. Right, so subtraction, addition, right, but the subtraction only works at a certain time period. Now I'm not going to bother with the output side yet. The actual output is what is going to be turning this circuit on and off, so I can leave that for now, because this section is going to be completely AC decoupled and isolated. So that basically has to be connected to this other opto-isolator down here, but it'll all be reversed, it'll all be the other way around, because it's the other half cycle which is negative. So when that coil's positive at the top and it's low, it's high at that end and it's low at this end, for the circuit down here it'll be the other way around, because it's AC, alternating current, that's what it is, it alternates, it changes polarity all the time. So this end is going to be high for this circuit down here, right? And it can get extremely confusing, but it's not going to interfere with that one, because when the polarity is reversed, when this end is high, nothing's going to happen, because this LED can only conduct in one direction, so it won't turn on. It'll only turn on when this is high and this is low. If it's the other way around, it's off, it won't come on, so it's not going to interfere, and there's no conduction of energy through there whatsoever when it's reversed. So that's going to isolate all these problems I've been having with all them diodes. So I can tap directly onto so let's just see, that's low on that one, so that will be my high on this one. So I've got to think in a minute now, because I'm getting confused. It's easy to do. So that's in series with my off coil. So because these coils that are coming in that are connected to these terminals will both be in series, and they'll work both ways. So let me think a minute. Sorry about the silence, but my brain has to work a bit. I'm going to colour code everything, right? So I'm just going to change the colour code of that. So I don't get confused. I'm going to make it red, so I know when that's high, and this one is low. I'm going to change the colour of that, so it doesn't, so I don't get so confused, right? So because I'm pretending it's the other way around right now. So that's low, that's high, and it's a lot easier when you do it like this as well. And so this will be high for this one down here. So what I have to do is let's see, is that going? Oh, I think that has to go. That has to be connected directly to this one. I think that's right. You see, I've been trying to think about this all day, and I thought I need to draw it out because I can't make head and tails of it in my head. It's just so confusing. But these colours would be reversed if the other side was high, and because I've got the high side on this cycle going through my off coil, I'm thinking, hang on a minute. So that end is, this end is going to my, this end is going to my high side there. So this end wants to, oh hang on a minute, just a minute, I've got this all backwards here. Get rid of that a minute. Oh, I'll just drink some coffee and try and think. Oh yeah, of course I want to be there. So my high wants to go to there. For that one. Oh, wrong one. Oops. No, that's right. No, it has to go for this resistor. Duh. Hang on. Right. Let's see. What have I done wrong here? Hang on a minute, I've got that wrong. Silly me. This wants to be mirrored. Hang on a minute. Flip. Right, that's better. You can see what I'm doing now. Right, that's right. Now, just get the other bit right. I'll just zoom out a minute. It looks better from a distance, but it's probably, you probably can't see it too well. Yeah, just give me a sec. This is the crucial part. If I get this right, I'm halfway there, because the rest of it will be a sin. Should be, because they're independent circuits. You see, they're both conducting the same AC signal, but switching each way. But it should be a lot easier to sort this out without, and I won't be having any feedback into my trigger coil circuit. Oh, why won't this zoom out in more linear steps? Just a minute, it jumps too much. Let me just see if I can adjust my stepping, my units. That's not it. Defaults, what's this? I want the zoom thingamajig. Just the zoom. That's not it. Must be under view. Screen grid. That's not it. Oh, zoom. It's jumping too bigger steps for me. I want it a bit smaller than that. Where's the zoom thing on here? Zoom level. That's not going to help. These are shortcuts. That's not going to work, does it? Oh God, I'll just leave it for now. Getting sidetracked. Right, so I want that one connected to that one, I think. And my ground, my relative ground on this side, well, that's positive on there because I've switched the colours around, but that would be the ground on that one. So the ground for this other one would be, oh shucks, I've got it wrong. See why I'm confused? I bet you're confused. So the ground would be that one, I think. So where's my positive come? Oh damn it, that's the positive one though. Silly me. Hang on, undo. Hang on. This is what it's like when you're trying to design a circuit. It's very, very confusing. So that's the ground, right? So I want a ground from here. I know I've got wrong. Add connection. So I want ground up to there, I think. Well, let's see. And that should be. And that's in series with that coil. It goes more positive. Hang on a minute. Let's see. Positive signals there. I've got to remember it's in series with that coil. I don't know if anyone's talking to me. I haven't got the chat open, by the way, on YouTube, so I won't be able to see it at the moment. Maybe I should open up YouTube and just preview, and just in case somebody's trying to talk to me. Well, I think. Oh, got feedback now. Oh, that's no good. That noise is terrible, I know, sorry about that. Yeah, I can't monitor the chat on there because I get too much feedback. Hang on. Anyway, yeah, maybe I should put the noise cancellation on. Hang on. Noise suppression, that should be a bit better, but I'll sound muffled now. Right. Oh dear, this is confusing, it really is. It's confusing. I mean, you can see what I'm up against when I'm trying to wire this stuff up. AC is such a pain in the backside, it really is. DC is a lot simpler. Right. So when that's positive, I'm putting my coil, coming out the top, subtracting that goes up there. So when that's positive, it's going through there. So basically my positive wants to come out this end. So my positive would be to that one. Right, I think about right. So it's only connected where it's got the good dot. You know, where there's a dot, that means it's connected. Where the lines cross, they don't mean a damn thing. These lines are not connected. Oops, I need to escape from that. These lines can move about, but they're basically not connected to that other line. The colours are different anyway, if you look. Anyone who doesn't understand electronics, you'll know that where there's a dot, that's where there's a connection. Right, let me think, I've got this right, finally. Right, so positive signal coming down, going through, so positive's coming up here, all the way around, through there, and it's returning to negative. Right, okay, I'm just following the trace, it's called trace route. I'm doing this by brain work though. Now, let's imagine it's the other way around. Yeah, I got something wrong. I made a mistake, because that's not going anywhere. That's not going to go anywhere. So, this connection, my ground connection, which is that one, I'm just going to delete that. My ground connection really wants to be going to that one. Connection, it's actually getting really confusing. Let's just try this. Right, let's see. Let's just trace this out. So, instead of positive coming down here, I'm going through that coil, coming back, I'm going all the way up there. We now have, oh shit, that's still not right. What am I doing? Of course, positive comes from up there. Yeah, silly me. So this, I've done it again. Undo that one. positive, actually. No, ground. Should be. I'm getting completely confuzzled now. My ground wants to come from there. But that positive is wrong. So, hang on a minute. I've got this wrong, haven't I? This is wrong as well. So, this wants to go to that one. Yeah, silly me, I've colour coded it, now I'm ignoring it. Right, so positive's coming out, it's no longer going to go through that one, so it'll go down through this one. And the return is going to be going through here. That's now that becomes negative. So my negative wants to go. Oops. I'll get there eventually. I'm just gonna. I'm thinking it must be here, it must be this one. That must be right, because that one is going to subtract from that one. And that one, that's reversed. Oh, let's see. I've got a headache. Again. Oh, come on, let's see. Right, so let me just reverse these colours because they are very confusing. Right. Properties, colour. Now I'm just going to undo that, use my own colour thing. A minute. Just going to make it all black again because it's less confusing for me. Right. Right, so what I'm going to do is I'm going to type some stuff. High, low, right, I'll just reverse these labels, it's a lot easier than colour coding. Right, that's low. Subtraction. Yeah, that's right. Imagine this is all reversed. High. Low. Subtraction. I think that wants to be on this side. Let's just see. Subtraction on that side is that one. No, that's right. I think that's right. So, yeah. Right, let me just copy that. Let's just start again, because it's very confusing, this. Right, that's... When that's low, let's get that. H, copy. Put that there. My memory's so bad, I can't even remember what I'm doing. Right, so when this is... when this one's high, that one's low, right, that one's around here, right? Can't remember shit. Sorry about language. Right, so this is high. It's going through that coil, it's in series, and this coil is not doing anything at the moment, so I've got high coming through this coil, going all the way back up, that's right, and this comes back, that's low, that's correct, right, so it's basically, I've just got to swap these labels around to help me, because by the time I got up here, I'm thinking, what the hell was I doing down there? It's logic stuff, logic circuits, they're very confusing. 10 noughts or something make a 1 or something silly, I don't know, yeah. So this is subtraction circuit, so when that one's low, and so this is high, so this is on, right? This coil basically springs into action, subtracts the voltage, and that goes lower and turns it off. Actually, I'll go on YouTube just a minute. I'll just go and check to make sure to see if anyone. So I'll go on here a minute. This is going to get laggy. I can go on my computer just to check see if anyone's talking to me. This should be muted because I'm live on the same computer, so it won't be bad. Oh, nobody's watching anyway. Oh, I'm going to get bored. I'm going to sleep. Oh, let's see, I haven't refreshed yet. Oh well. No one's watching. No worries. Right. Turn that back off again. I was watching Snooper earlier. Go back on there. Let's see. So that's high. That's correct. So I have to double check all this. So when that's high, this end is not going to conduct because it's reverse polarized, you see. That's correct. So high. Yeah, that's correct. Now when this coil goes low, it'll just subtract that voltage that's going from this one, and that will go low, and that will turn off the optoisolator. And so that's correct. So now I need to reverse these labels so that we can work out the other one. So it makes it easy when I do it like this, because it's easy to forget what you're doing. So when this coil is now, the AC has switched around, so now this end becomes high and this end becomes low. So now what do we have? We have high coming down here, which is basically that's going to be turned off. So that's going to go from my resistor to my optoisolator circuit, that's correct. And so the high is now coming down here. So I'll highlight net. So I'm highlighting that net so we can see that that's going to be high now. This is going to be low. Well, no, it's not. It's going to be low. It's going to send a low signal through here. Alright. inactive at the moment. So we actually, just a minute, yeah, let me think about this a minute. So if that's low, and that's to my ground on this one. So basically when this one goes high on this side, you would turn that off. Yeah, that's right. That's right. So when that's low, we have a low signal going through this coil. So this would be low, which is pulling that down, which is correct. And when that off coil basically goes high on this side, it will turn it off. So that's right, I think. Because it's going to ground. Yeah. It's confusing because I've got these series coils, these coils that are in series, and it's very nightmarish. But actually, I've just had a thought. Yeah. Right. Anyway, I think I might as well disappear for a bit. I'm just trying to think about this because I tell you, it's so confusing. I'm probably doing it wrong. Probably doing something wrong here. It's because I can't see it all at once. I need to bring this closer actually. Let me just grab this lock. Oh, that's no good. I just want this. Oops, what am I doing? Oh, I've got the wrong. Let's just grab that. Move it up a bit. Oops, that's crossing over there. Hang on a minute. I need to bring that. Try and tidy this up a bit. Right. Oh, it keeps moving this up here. I don't want that to happen. Right, you bugger. I'm just going to grab you and you. That's better. Just bring you a bit closer so I can see what all I'm on screen. That's I see what I'm looking at now. I'm just saving it so I don't lose it. My brain just doesn't work the way it used to do. I'm going to disappear anyway. I need some more coffee. So let's see. But I think that's right, because when this is reversed, this off coil would go high, and it's going against the negative rail on this opto isolator, so it would do the same thing. It would effectively turn off the opto isolator when it goes high. So this coil, when it switches around, it goes low, which would pull down the biasing on that side. So when this coil, the exit coil on here, switches and goes yeah, I think that's right. So when this exit coil is in series with that coil there, it goes low to turn that off, and it actually goes high to turn this one off. So that's right. Because it's connected to the input on this one, of the high side, and it's connected to the low side on this one. So it would still do the same thing without any problems. It's just, I tell you what, electronics can be a real pain in the ass. So let's just reverse these labels a minute again. Low, high, just moving my letters around so it's easy to work it out. H, low, right, so yeah, because when that's high, coming through, this coil is not active yet, so high will pass straight through that coil. It won't do anything down there because it'll only conduct one way. So high will come through up here, round here, turn on my opto isolator up here, which is what I want. And when this coil turns that off, it basically has to go low, which is what it would do. So that connection would go low, which would turn that one off. It won't do nothing to that, because that's not even getting a high signal right now, because it's actually getting it's not getting a high signal from this end, it's actually getting a low signal, so it's a low there and a low there. So that one won't be working. Right, that's right. I'll swap my labels around again. Now it's reversed, and high's coming out, it's not doing anything here, that one's turned off, high comes through here, goes from my LED, opto isolator, goes, yeah, it won't affect that one because that's the same polarisation on both sides, so that's going to get high there more than it is there, so that won't even come on. Let's see, I'm just to make sure I've got a circuit here, proper circuit. So high comes through here. Pass through to low. And when this one goes, when this one flips and it goes low, no, this one goes high actually. This is the confusing one. High. These coils are connected on here, they've got a DC resistance of 4 ohms, so it's literally very low impedance. Yeah, so when that end goes, when the high signal passing through here normally goes through there, it's going to the low for the coil. But when this polarization flips, that end goes high, this end goes low. So that would turn it off, yeah, that would turn that one off, I think. Yeah. Anyway, I've got a headache, so yeah, you can see why I'm having problems with this circuit. It's just very confusing. AC is always confusing. But I'm going to try and make this other part of the circuit down here more DC, because it's only going to receive each one of these blocks is only going to see one side of the AC anyway, so it'll effectively be DC. But that'll be 1/2 of the cycle, DC side. That's why I've got capacitors there, because I can't put capacitors everywhere because of the AC, it would interfere with it. So that would effectively be 1/2 of the cycle. It would effectively be a DC side, and that would also be a DC side, effectively, because it's switching half cycles, and it doesn't get to see. It would ignore the other half cycle. This block would ignore the other half cycle. It would only switch 1/2 cycle. So with this one, so I'm not going to have problems with that. It's just this part that's giving me a bit of a headache. Right, anyway, you can see what I'm trying to tackle. Anyway, the optimizer is the answer to the problem anyway. It's just making sure I've got the logic right. Each one of the outputs of the optimizers, this is IC2 and IC3 outputs, this will go to that top section, and this other one would go to the bottom section, and they're completely isolated, so I won't get any AC feedback or anything from there travelling back through the circuit, because it will be completely separate. So that solves those problems, really, if you get what I mean. So anyway, I'm going for now. I'll try and bring updates there on.